This is Electric Universe Geology, Earth News. Today we're back in the San Juan Mountains, basically southwest Colorado. This is the Rio Grande River, or the Rio Grande if you're from Philadelphia. That swings up here, comes around, goes up into the Continental Divide, up into here somewhere. And you have, according to the United States Geologic Service, three calderas. One here, one here, one here. They're supposedly volcanic calderas. I don't think they're volcanic. I think that they're vortices within vortices within vortices. But they seem to be electrical in nature. And coating this entire area is either basalt or welded tough. The whole area. And it's all downwind from this clockwise phenomenon. So the top layer being welded tough and basalt for such a large area, and it continues on down by Taos. There's so much basalt. It just completes the circle all the way around, where you have red hot dust at the end of the process, coating what's sticking up above a flood. So let's look at some other USGS maps. So here's the USGS map. There's a link at the bottom of this video for this map, and it has a key to all the different minerals with the different colors. It's fascinating. You can use the one that's maximized for the screen. It's 5 megabytes, doesn't take that long to download. But here's that one formation where the Rio Grande comes around it. This is a caldera. This one's not. This where the Rio Grande River is. Here is up here. I hope the cursor's working. This is Lake City caldera, and this is the Silverton caldera. All of these have gold, a lot of gold, especially these two over here. This one too. It's just rich in minerals. Some of the formations, by the way, that aren't volcanic or welded tough are quartzite, which are high grade metamorphic. There's an area just south of Silverton. I'll do a video on that shortly. But this gives you an idea of the way these things look. These are electric calderas, not volcanic. You'd think you'd see vents. Vents would be so much more easily distinguished than welded tough, where the molten material comes out of the ground. It makes really distinctive formations that would be less prone to erosion than the welded tough downwind. And the welded tough falls apart because if you go downwind a few miles, it's not going to be welded anymore unless something is keeping the dust hot. Dust in the air is going to cool off very quickly, surrounded by air, unless there's an electric component keeping it hot for a distance, like an aurora type event, a dichotron instability. So I hope you take a chance, take the opportunity to download this and then look at Google Maps and look at the area and see what this volcanic area is actually composed of. And I think it's red hot dust from the sky. Thank you. See if I can turn this off.